Clouds have captivated the human imagination for millennia. They float above us in ever-shifting forms, mysterious and beautiful, casting shadows over the land and bringing rain, snow, or sometimes nothing at all. Yet despite their everyday presence, clouds remain a source of wonder and curiosity. How do they form? What shapes them? Why do they look the way they do? The science of clouds is a fascinating study that connects the atmosphere, weather, and the broader natural world in ways that are both simple and complex. Understanding clouds is about more than just knowing the weather forecast. It's about delving into the heart of the Earth's atmosphere and appreciating the delicate balance that sustains life on our planet. To understand clouds, we must first look at the basic building blocks, water and air. At its core, a cloud is simply a collection of tiny water droplets or ice crystals suspended in the air. But the journey these droplets take to become a cloud is anything but simple. It all starts with water in its liquid form, whether in oceans, lakes, rivers, or even the soil. As the sun heats the earth, this water begins to evaporate, turning into water vapor, an invisible gas that rises into the atmosphere. This process, known as evaporation, is the beginning of the cloud's formation. Once the water vapor is in the air, it continues to rise. The higher it goes, the cooler the air becomes. This is where things get interesting. As the water vapor cools, it reaches a point known as the dew point, where the air can no longer hold all of the moisture. At this stage, the water vapor begins to condense around tiny particles in the atmosphere like dust, salt, or even pollen. These particles are known as cloud condensation nuclei, and without them, clouds wouldn't be able to form. The water vapor clings to these microscopic particles, transforming back into liquid water or ice crystals, depending on the temperature. When enough of these droplets or crystals cluster together, a cloud is born. This process of condensation is what creates the fluffy, white clouds we see in the sky. But clouds don't always look the same. They come in many shapes and sizes, each one telling a different story about the atmosphere above. Some clouds form high up in the sky, wispy and thin, while others gather closer to the ground, dark and ominous. The type of cloud that forms depends on a variety of factors, including temperature, humidity, and air pressure. These variables work together to create the diverse range of clouds we see, from the delicate cirrus clouds to the towering cumulus clouds that often precede a thunderstorm. Cirrus clouds are some of the most distinctive clouds in the sky. High and wispy, these clouds form at altitudes of around 20,000 to 40,000 feet, where the air is much colder than at ground level. At these heights, the water droplets that make up clouds freeze into ice crystals, giving cirrus clouds their feather-like appearance. These clouds are usually thin and white, and they often signal fair weather. However, when cirrus clouds begin to thicken and cover the sky, they can be a sign that a change in the weather is coming, as they sometimes indicate the approach of a warm front or a storm system. Cumulus clouds, on the other hand, are the stereotypical cloud that most people picture when they think of the sky. These clouds are thick, puffy, and often have a flat base with a towering, billowing top. Cumulus clouds form lower in the atmosphere than cirrus clouds, usually at altitudes of 2,000 to 6,000 feet. They are the result of rising warm air that cools as it ascends, causing water vapor to condense into the familiar, cotton-like shapes. Cumulus clouds are typically associated with fair weather, but when they grow larger and darker, they can develop into cumulonimbus clouds, which are capable of producing thunderstorms, lightning, and even tornadoes. Cumulonimbus clouds are the giants of the cloud world, towering as high as 50,000 feet and bringing with them some of the most dramatic weather events on Earth. These clouds form when the atmosphere is unstable, and warm air rises rapidly, creating powerful updrafts. As the air cools and condenses, it forms a massive cloud that often has a flat, anvil-shaped top. Inside these clouds, violent winds swirl, and water droplets collide, creating static electricity that eventually discharges as lightning. Cumulonimbus clouds are the source of thunderstorms, heavy rain, and hail, and they are a reminder of the incredible energy that can be stored in the atmosphere. In contrast to the towering cumulonimbus clouds, stratus clouds are low, uniform, and often appear as a gray blanket covering the sky. These clouds form in stable air, where there is little vertical movement. Stratus clouds usually don't bring heavy rain, but they can produce drizzle or light snow, depending on the temperature. When these clouds form near the ground, they are called fog, which is essentially a cloud that touches the Earth's surface. Stratus clouds may not be as dramatic as their towering cousins, but they are a common sight, especially in cooler, wetter climates. The formation and behavior of clouds are closely tied to the weather. In fact, clouds are one of the most visible indicators of atmospheric conditions. By observing the types of clouds in the sky, meteorologists can make predictions about the weather. For example, high, thin cirrus clouds often indicate that a storm is on the way, while low, thick nimbostratus clouds can signal an approaching rainstorm. The way clouds move can also tell us a lot about the winds higher up in the atmosphere, which can affect weather patterns on the ground. But clouds do more than just predict the weather, they play an active role in shaping it. One of the most important functions of clouds is their ability to regulate the Earth's temperature. During the day, clouds reflect some of the sun's energy back into space, keeping the planet cooler. At night, clouds act as a blanket, trapping heat that would otherwise escape into space, helping to keep the Earth warm. This balance between cooling and warming is essential for maintaining a stable climate. Without clouds, the Earth would experience much more extreme temperatures, both hot and cold. Clouds also play a crucial role in the water cycle, which is the continuous movement of water between the Earth's surface and the atmosphere. After water evaporates and forms clouds, it eventually returns to the surface in the form of precipitation, rain, snow, sleet, or hail. This process helps to distribute water around the planet, replenishing rivers, lakes, and oceans, and providing fresh water for plants, animals, and humans. Without clouds, the water cycle would break down, and life as we know it would cease to exist. The science of clouds is deeply connected to the study of climate change. As the planet warms due to human activity, scientists are closely monitoring how clouds are responding. One of the biggest questions in climate science is how clouds will influence future warming. Clouds have a complicated relationship with climate change. In some cases, they may help to cool the planet by reflecting more sunlight, while in other cases, they may contribute to warming by trapping more heat. Understanding these dynamics is crucial for predicting how the Earth's climate will change in the coming decades. For instance, in polar regions, clouds play a particularly important role. As sea ice melts due to rising temperatures, the ocean surface absorbs more sunlight, leading to further warming. Clouds can either amplify this effect by trapping heat or mitigate it by reflecting sunlight. Scientists are working to better understand these processes in order to improve climate models and make more accurate predictions about the future of the planet. Climate, clouds are also key players in more immediate weather events. Thunderstorms, hurricanes, and tornadoes all rely on specific cloud formations to develop. Thunderstorms, for example, require cumulonimbus clouds, which form when warm, moist air rises rapidly and condenses at high altitudes. The energy released during this process powers the storm, producing rain, lightning, and strong winds. In extreme cases, thunderstorms can spawn tornadoes, which form when the wind inside a cumulonimbus cloud begins to rotate. Hurricanes, on the other hand, are massive storm systems that form over warm ocean waters. They are fueled by the evaporation of water, which condenses into clouds and releases energy. As the storm grows, it organizes into a rotating system of clouds and winds, with a calm center known as the eye. The clouds in a hurricane can stretch for hundreds of miles, and the storm can last for days or even weeks. While hurricanes are destructive, they are also a testament to the power of clouds and the energy contained within the atmosphere. One of the most fascinating aspects of clouds is their ability to take on an almost endless variety of forms. From the delicate, wispy strands of cirrus clouds to the towering, thunderous masses of cumulonimbus, no two clouds are ever exactly alike. This diversity is a result of the constantly changing conditions in the atmosphere, including temperature, humidity, and wind. The sky is like a canvas, with clouds serving as the brushstrokes that paint an ever-evolving picture. Even though we now understand much about how clouds form and behave, they continue to hold a sense of mystery and wonder. Looking up at the sky on a summer day, it's easy to lose yourself in the shapes and patterns of the clouds as they drift by. Some might look like animals, others like castles or mountains. Children and adults alike have spent countless hours gazing at clouds, letting their imaginations run wild. Despite the scientific explanations behind their formation, clouds still retain an almost magical quality, reminding us of the beauty and complexity of the natural world. As we continue to study clouds, we uncover new insights into how they work and how they affect the Earth. Advances in technology, such as satellites and computer models, have allowed scientists to observe clouds in greater detail than ever before. These tools help researchers understand how clouds are changing in response to global warming and how they might influence the planet's future climate. The study of clouds is an ongoing journey, one that promises to reveal even more about the intricate workings of our atmosphere. In conclusion, clouds are far more than the Earth's weather and climate systems. From their formation through the water cycle to their impact on temperature regulation and weather patterns, clouds are essential to life on Earth. They remind us of the delicate balance that sustains our planet and the beauty that exists in the natural world. Whether we view them through the lens of science or simply as part of the everyday landscape, clouds are a constant presence in our lives, shaping our environment and inspiring wonder.